Hello everyone, good afternoon. My name is Aftab Hussain. I'm a faculty member at IIIT Hyderabad. I will be presenting a paper on an EV charging solution that we have come up with using Bison as a protocol network or a protocol layer, OCPP as the authentication layer, and 1M2M as a middleware layer. And all of those, I know all of those three are uh, can be new to you if you're not in this field. So I'll talk about all three of them. But here, I mean, the real interesting sort of innovation is the combination of the three and how we can leverage these three to sort of make EV charging a interoperable problem. Right now, what the problem is that if you have a vehicle of some type, it can be charged with a charger of some type. In some cases there is some interoperability, but if you want to build into the system the interoperability of your charging, we have to look at standardizing everything, standardizing how information is communicated with the server and back by an EV charger. So a quick background on IIIT Hyderabad's living lab. It's a very unique concept. It's the first living lab in India where we have converted the entire IIIT Hyderabad campus into a smart campus with something like 300 nodes deployed for monitoring water quality, air quality, energy outputs, and water networks, and so on. And for the nodes that have been deployed, the all the programming, the stack, the middleware, everything has been developed in IIIT from scratch, and we have basically made it open source as well. So one of the things in the title was 1M2M. I was telling you that I'll explain everything. One of the key things in this particular paper is integration of EV chargers with 1M2M platform, which is a middleware platform for smart city infrastructure, which has also already been assigned or has been acknowledged as the de facto standard by the Smart City Mission of India as well. So if we want to develop something as a interoperable and universal system for deployment in India, we should use 1M2M as a middleware architecture. So typically what ends up happening is that if you look at a smart city deployment, you will have sensors on one side, communication layer on one side, and then this data lake that is sitting here in the middle. And then you have applications on the other side, which means, and the applications are querying, the data lake in various ways, depending on how you want to develop those applications, like either for dashboarding or some intelligent solutions. So this data lake is where all of your data about the city is sitting. And that data has to be structured in a specific way. It has to be databased in a specific way so that it's queryable in multiple ways. And that is enabled by the 1M2M platform, and which is why we are using it for our EV charging solution. Now, the other acronym that I had used in the title was Bison. Okay, now this is another interesting sort of communication protocol. It's a novel communication protocol that has been very recently developed on the 802.11 standard. It is sub gigahertz, 865 to 868 megahertz in India. So it's an ISM based protocol, which means you don't have to have a license to deploy Bison routers. It's a mesh protocol, which means it forms structures like this. You will have different Bison nodes connected to each other in some kind of a mesh. And if one of those nodes is connected to the internet through some protocol, let's say TCP/IP or LTE protocol, the entire mesh gets connected to the internet. I mean, for example, so this node can relay information through this structure all the way up to the cloud and back. Right? This is how the Bison communication works. Very briefly, I will say that we have deployed around 60 Bison nodes across IIIT Hyderabad campus in the form of streetlights. I mean, there is another paper in AppsCon that we just presented about it. The details are there. But what this network does is that, apart from the streetlight control that we get, of course, the other thing that it does is it enables us to deploy any Bison node anywhere in the campus. I mean, if any Bison node is there in the vicinity of one of these streetlights, it will attach to this network. It'll be a part of that mesh and will suddenly start communicating with the cloud. So it's as if, like, for example, if you go in a Wi-Fi enabled city and your phone is always connected to the cloud, it's like this. If you go to a Wi-Fi a Bison enabled campus, and if you have a Bison device, it will always be connected to the cloud, no matter where you are. So this freedom has been given to us by our streetlight deployment, and this is what we are using for deploying the EV charger. So in the EV charger that we are deploying, we do not use Wi-Fi or LTE or any other communication protocol because Wi-Fi already exists on campus. So this is the structure we want. We are basically using. We have the user interface and the EV charging system here. We have the user, of course, feeding in information about themselves. So we have to have a user authentication that's built into the system. That authentication has to basically go all the way up to the 1M2M platform, which we are using for both user authentication, like keeping a track of the users, as well as how much, for example, in this case, how much money they have in the wallet, because that is how charging basically payments can take place. So that authentication basically has to go through the Bison network in the form of an OCPP. OCPP is again another protocol that is used by international community for charge points. Okay, so it's an open charge point protocol. So packets are structured in OCPP. They are transmitted using the Bison protocol, and they end up in 1M2M data lake. So all these three protocols, which are all sort of open source and standard protocols, are used in this technology. So from a physical point of view, at the end, because you are basically having your system here, of course, you will need a microcontroller that is going to control, like interact with the user. That is one. It is going to control whether or not charging needs to be done. That is another. And then it has to also communicate over Bison with the 1M2M platform. So for that, we have basically used a Raspberry Pi, board for doing all the computation, and we have used a Silicon Labs based, Bison SoC for the Bison communication. So this is how the node looks. We have a display because the user needs to interact with it, whether or not whether charging has happened or started or stopped, the user needs to be told. We have a power meter, obviously, because it's a charging station, so we need to know how much power is being consumed. There is a relay, there is a emergency stop switch because everything is operating at 16 ampere 220 volts. And all of so if you look at this 220 volt supply to the load, we are basically tapping into it to obtain all the power for all the other electronics as well. So, we are getting the Raspberry Pi and all the Bison modules and displays and everything else powered here, whereas the power meter and relay are on the load line. So this is what the user flow looks like. We have the welcome screen. So I always say that this kind of a charging system is like an ATM for charging. I mean, so whenever you go to an ATM, you authenticate yourself and tell how much money you want, and the money comes out. In this case, you authenticate yourself, and basically, so user swipes the user RFID, and then when the user is authentic, it basically says how much balance is there in the user account, which basically comes from your 1M2M wallet. And you have to again then enter the value of, let's say I want 100 rupees ka charge or 50 rupees or whatever, X amount of money. And that is then when the charging starts, and then as soon as the specific amount of charging is done, the charging stops and the user is notified. So this is the same communication that I was saying is, we are talking to the charge point at one, which is the actual charging station at one point, the border router, which is not there because this charge point can be a part of a big mesh of Bison, so it can be somewhere else. Border router is somewhere else, and then from the border router we are talking to the cloud, and which is, let's say, communicating with the 1M2M server. So that is another location. So all of these three locations, the information is going back and forth in terms of setting up of connections and everything, authentication for the ID and amount of charging. It goes all the way up to the 1M2M server. It tells the confirmation for the transaction back, then the charging starts. Eventually the charging stops based on the power meter output, and then charging completed, transaction then also has to go all the way up to the server. Here, actually, one of the things that we had to really innovate is how to set up users in such a way that they can actually charge at any charging station, right? That's what you want. Like again, in the ATM example, if you have a card, you can go to any ATM you want. And any ATM can accept any user. So both ways, it should be independent, interoperable. So one of the ways in which we did this is in 1M2M, everything is structured in the form of a tree of of information like nodes and their containers and their container instances and everything. And in this case, what we did is we made two separate trees for the user and the charging stations. Okay, so all the users are in a user tree and all the charging stations are in another tree. So what happens is then authentication needs to be done for a user. The EV charging station can ask for whether a user exists or not and how much how much money they have in their wallet, which can be asked from the user tree, and it appears that query appears as a container instance. So every time that happens, it again the system has a log of all of those things as well. And once that communication is positive, or the server gives a go ahead for charging, the charging information then comes into the charger database, which is also again tells where the location of the specific charger is and how much charge has actually been given and so on. So by querying these, you can basically get all of the information. This is the deployed charger, and you can see that we have connected it to a bike because it's a 16 ampere charger. It's just for bikes to use, not for car charging. This is the team that has worked on this. Thank you.